Here's the outline for today. We'll be setting up our coding. Hello and welcome to Zypher Games Workshop. Today we'll be going over how to use Zypher's secret engine SDK to empower our on-chain card games. Here's the outline for today. We'll be setting up our coding environments. We'll be creating a card game with NFTs. We'll learn how to use secret engine ZK Shuffle and learn how to reveal cards after using ZK Shuffle. And we'll try to design a basic game flow for our card game. Okay, so setting up our coding environment. For these projects, we'll need Node together with npm installed in our system. Once we have that installed, we want to run npm init to create a new project. In this project, we also need hardhead, so we'll install hardhead with npm install hardhead. And once you do that, you can either do npx or npm hardhead init to create a new hardhead project for our Solidity contracts development. And finally, we'll use npm install Zypher's secret engine and also Open Zeppelin contracts for our smart contract development. Okay, so for our game, we'll need to have an NFT. And as you can see in this gamecard.sol file, we have written a game card contract, which is an NFT. So we import this ERC 721 standard from Open Zeppelin and inherit our contract with the 721 standard. So for our constructor, we've just specified its symbol and name. And more importantly, we have a batch mint function in which our player can call to mint their own NFTs. And inside this function, we have an internal mint with the tag function. So the player can mint the NFT card. And also we have a create a tag value function that will create a random attack value for associated with this NFT. Now we're ready to create our game contract and also add players playing cards. So firstly, we'll have a constructor in this game contract in which we'll pass in the NFT. And this is just the gamecard.sol NFT that we had in the Lex section, and we'll store it in the card set variable. We'll also have a private DEX mapping, and this just maps from our player's address to the card IDs of the NFTs that our player wants to play with. And we have some associated functions, get deck with the our player's address to get his NFT playing cards. We'll have some other functions, like for example, adding a NFT card and removing an NFT card. We can also add a view function like this one called the valid deck, and this just checks that our player actually owns the NFTs to make sure that it's valid and he can use that. He can use the cards to play in our game. Okay, now we are ready to start designing the actual matches. For this, let's just call them duels in this case. So here, as we can see, we'll have a duel state, which defines the state of the duel that it's in. We also have a duel struct to hold different data for the duel. And for this, a lot of it is related to our card information and also the ZK shuffling, in which we'll go over the details later. In this case, we also have the duel ID to track what duel we are currently playing with, and have a dual variable that just hold the struct information above. And then we'll have a new dual function to kickstart our new duels. Okay, so here comes the fun part. We're going to use Zypher Games' secret engine SDK to do our ZK shuffling. First and foremost, let's look at the top of our game contract. Here we've added two different verifiers. One is the shuffle verifier, and the other one is the reveal verifier for our ZK proof process later. Then, since our card game has two players, we need to have each player generate a special key for our reveal verifier later. And for this, we're moving off chain. And here we've just written a game.spec file for generating our keys. And as you can see here, if we call, we import our secret engine package. And here, if we call secret engine.generate key, we'll have a key with a struct like this. And once we get that, we can pass the key into our function on chain to have it stored. And for this, we've just defined a join dual function that will take in the keys, and it will store our player's keys. And note that for the second player that joined, our reveal verifier can aggregate the key, and this creates a special game key for our duel. All right, so in our next session, we have set up and created our dual scam key. We can now move off chain to our script and fetch the game key. Once we do that, we can work with secret engine in order to set up the key. And once we do that, we need to have each of our player to shuffle and submit their deck on chain. And for this, we'll have this function. And what it does is that it will first mask our cards and then shuffle them, and then we submit our cards on chain. So this is what the submit deck function looks like on our contract. So if we go to submit deck, it basically does some checks above, and then once we set up the input, and we can have our proof be verified by our shuffle verifier. And once it does that and the proof passes through, it will store player stacks on chain. And we need to have both players do that to submit both of the decks. And after this, we also need each of our player to also shuffle the opponent's deck and submit that on chain. So we also have here the shuffle deck function that acts very similarly to our submit deck function above. So it does some checks, sets up the inputs, and together with the proof, we have this verified by our shuffle verifier. And finally, it will store the opponent's decks on chain. Now we have both players' decks are shuffled. We need to have the players reveal their opponent's cards. So from our shuffle deck function before, at the end here we have updated both players' decks. Say that now the players are ready to start the duel, and they want to reveal the first three cards. of the deck. We can go into our script, and now let's fetch both players' decks. And in this function, we work with secret engine to reveal the cards, and then we submit these reveal tokens to our show opponent hand card function on chain. So let's take a look at that. Okay, so this function first will check the reveal token. So with the proof, we pass in the require valid reveal token function to be checked by the verifier. And after that, we have a review variable which is on storage. Once the reveal tokens have been verified, we will push the reveal tokens to the player reveals respectively to store the reveal tokens. And once we do that, we can start revealing the tokens for each player. So we'll come back to our script, and again, we fetch the deck of both players, and with the players' decks and the reveal tokens and their hand, we can pass into we can write this print hand cards function, which will call secret engine's unmasking functions to unmask our cards, and in return, we'll be able to get our original NFT IDs. And this part concludes the revealing flow of our game. Now let's add the play card function to enable our players to play the cards. So in order to do that, let's go back to our script. We need to pass in this information, for example, player's hand and the deck and the index of the hand that they're playing into this play card function, and have our secret engine to reveal the card. Once we do that, we can submit that on chain by calling our play card function, and we've just added that here. So our secret engine will create the reveal token and the proofs. So this play card function will do some simple checks, like for example, checking that the user has the NFT, and then we'll pass the reveal token and the proof to be revealed by our reveal verifier. This is just so that we're saying that the card that we're playing in this case is valid, and then we'll add that to our reveal storage variable. And then finally, we can add some additional gaming logic, like for example, player's life, and have the cards attack values attack player's life. And once that goes down to 0, then we can end the game. Just adding some more gaming logic to make our game more fun to be played with. So this wraps up the flow to use Secret Engine for our card game. For complete information of ZK Shuffle, please see Zypher Games workshop documents. Have fun hacking.